the unit circle. Okay, the unit circle is super important. So you will be using this all the time in pre-calc and AP Calc. So you should know it. Really important. All right, so it says we do not always want to use rounded answers when dealing with degrees. So it's okay for us to say go 30 degrees in this direction, but it's really awkward for us to be like go 30.2634 blah, blah, blah degrees. That's weird. Okay, so we can have more precise angle measurements, in particular when we're dealing with circular objects, when we use something called radians. So I'm sure you've seen on your calculator, there's, when you hit mode, you have a choice between degrees and radians. Okay, we're going to learn about the second thing, radians. So anytime I'm dealing with something circular, like a Ferris wheel, or a bike tire, or the wheels in your car, right? If I'm talking about the speed I'm going, the angular speed, it's best to use radians. Okay, anything circular will use radians. This is super important in real life. Okay, so when we're going to be talking about radians, I'm going to use what's called the unit circle. Unit means 1 unit, right? 1. So this is going to be a circle of radius 1, centered at the origin, whose equation is x squared plus y squared equals 1. So if you remember, we talked about x minus h squared plus y minus k squared equals r squared. You guys remember that formula? So in this case, we have 0, 0 for our center, and our radius is 1. Okay, so when I talk about the radian measure, it's basically going to be the length of the arc to any point P along the circle. So if I talk about this distance right here, this length of the arc, that is my radian measure. Okay, it's telling me how much I'm opening on a circle of radius 1. Okay, so if I want to talk about 0 radians, that's like this is just totally flat. 0 radians would be right there. It's just totally flat. It's not open at all. If I want to talk about maybe 45 degrees, right? Here's what my angle would look like. Okay, but 45 degrees, I would need to figure out what radian measure that is. Okay, so like I said, it's the length of the arc. So we're talking about arc length. Do you guys remember that from geometry? Arc length. You may not remember the formula, but that's okay. So it says, what is the length of the arc if we go all the way around the circle? What do we call that if I find the length all the way around a circle? The circumference, right? So the circumference is going to be 2 times pi times r. So in this case, it'd be 2 times pi times 1, or 2 pi. So it'd be going all the way around like that. So if I want to talk about 360 degrees, 360 degrees is the same as 2 pi radians. All right, so the next thing, so what if we go about, if we go halfway around the circle? How many radians would that be then? I go right around there. It would be pi, right? So 180 degrees is pi radians. Okay, so I can talk about what fraction of the circle I have and so on, and make it into radians. Okay, so if I talk about 180 degrees, we know it's pi radians. If I talk about 90 degrees, it's going to end up being pi over 2 radians. Okay, so it says in simpler terms, radian measure is a way to describe the angle measure using the arc length on a circle of radius 1. The circumference of the unit circle is 2 pi times 1 because your radius is 1. So your circumference is 2 pi. So the radian measure of a 360 degree angle is 2 pi. And you can write 2 pi radians, but radians is actually the like if there's nothing listed, it's automatically radians. Okay, so find the radian measures that correspond with the following degree measurements. So if I have 180 degrees, we said that that was the same as pi radians. Okay, if I have 90 degrees, it's going to be pi over 2, right? 1/2 pi or pi over 2. So then what would 45 degrees be? Exactly, it's going to be half of that, right? So pi over 4. All right, now here's where it starts to get a little tricky. What if we talk about 30 degrees? I always think about how it's related to 180 degrees. What fraction of 180 is it? Yeah, it is pi over 6. Good. Does that make sense? Because 180 degrees was pi. So if I'm talking about 30 degrees, that's a sixth of what we have. It's 1/6 pi, right? Pi over 6. All right, but it does get a little bit harder. So if you need to kind of go back to what you've learned in chemistry, so a lot of you guys learned in chemistry unit conversion. So if you go from like miles to feet to inches, right? Do you guys remember all the unit conversions? Let's do that in this case. So if I have 270 degrees and I want to change it to radians, I would put degrees on the bottom and radians on the top. And I know that pi is the same as 180, right? Pi radians is the same as 180 degrees. And then I would just reduce it out. So if I have 270 and 180, it reduces out by 90. So I get 3 and 2. So this would be the same as 3 pi over 2. In other words, like 1.5 pi. Does that make sense? 1.5 pi. If you think about where it's located, 1.5 pi would be going around here. There's 1 pi, and another 1/2 pi. That's 270 degrees. Does that make sense? All right, 330. So let's try the same thing. So if I have 330 degrees, and I multiply by pi over 180, right? It reduces. I could divide by 10, so the zeros are gone. So then I still have 33 pi over 18, and that will go down a little bit more. So what can I divide by? 3? Yep, so I get 11 pi over 6. I don't know what you're saying. So 11 times
360 divided by 6.
I don't know. I don't understand how you're getting that. That's fine. Like, I don't know what you're doing to get that those numbers, but that's if it works for you, that's good. All right, so number 2, so write the radian measure next to the degree measures on the unit circle. So you guys are going to have a quiz that looks like this in a couple of days. Do you guys see this big circle? It's on the next page. It's going to be completely blank. You're going to have to fill in the degree measures, the radian measures, some points, coordinate points, x and y, yeah, that's it. So coordinates, degree, and radian measures. Everything you're going to need to know. Okay, so let's talk about just the radian portion right now. Okay, so for radians, we talked about if it's not open at all. So if I have a flat angle like this, see my 2 hands putting together? Alligators like not eating anything. That's 0 degrees, but it's also 0 radians. But if I open it up all the way around, like a hinge, all the way around, right, that's 360 degrees, but it's also 2 pi radians. So that angle represents 2 different things. So one was completely closed and one was completely open. So 0 and 360 degrees, which is the same as 0 and 2 pi radians. So over here at 180, we had pi. At 90, we said it was pi over 2. And at 45, it was pi over 4. What's your guess for 135 degrees? Yeah. What do you think its radian measure is for 135 degrees?
1 or 0.
No?
Or let's do pi over 4.
No. So let's think about it. So let's ignore the pi's. I have 0. I have 1/4. I have 1/2. I have something, and then I have 1.
2.
No. Not 2. Guys, think of your fractions. 1/4, 1/2. No. Guys, I did not think this was a hard question. 3/4, right?
Yeah.
Does that make sense? So I have 1/4 of a pi, I have 2/4 of a pi, which is 1/2, I have 3/4 of the pi, and I have 4/4. Okay, do you see what I'm doing? So I'm going around. All right, so this would be 3 pi over 4. And then the pi was 4 over 4. So then what about 225 right here? What do we say?
1 and 1/2.
1 and 1/4, which is 5 pi over 4, right? 1 and 1/4. And then I have 1 and 1/2, which was 3 pi over 2, right? So it's kind of like if you're going around and you're doing your numbers, you have 1/4, 2/4, 3/4, 4/4, 5/4. You don't have to write these. I'm writing them. 6/4, 7/4, 8/4. Do you guys understand that? If you go around 1/4, 2/4, 3/4, and you just reduce. So see how this one's going to be 7 pi over 4. Right there. Okay, so I'm going to erase all those. Oops. Too much. All right, so 3 pi over 2. So this one I said was 6/4, so this one's 7 pi over 4. All right, how about the 30 degrees? Do you guys remember what 30 degrees was? It was pi over 6. Okay, now I'm going to do every single thing except for the 45-degree ones, except for the ones that are in the very center of the quadrant. Okay, so I'll show you which ones I'm leaving out in just a second. Okay, so do you guys notice that I'm leaving out everything but this, this, and this. The ones that are in the very center of quadrant 1, quadrant 2, quadrant 3, quadrant 4. Do you guys see? Everything else has to do with 30 degrees because think about those angles, right? I have 0, 30, 60, 90, 120, 150, 180. Do you guys see I'm going up by 30 every single time? Okay, if you get confused, you can always resort to, like if I wanted to find 240 degrees and I wanted to write it in radian form, I could multiply by pi over 180. I could reduce. I have 24 over 18, which is going to be divided by 6. So I have 4 over 3 pi. So you can do that, and you can get that the 240 degrees is 4 pi over 3. So you can do that if you need to. But if you guys are taking your quiz, it's going to take you forever if you do that. So there's a shortcut. Okay, you want to learn the shortcut? Yeah, you want to learn the shortcut. It's going to make your life so much easier. If you're scared of fractions, this still works. It's pretty easy. Okay, so every 30, 60, 90, 120, 150, and all of those, every single thing I'm going to hit, I'm going to do 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, all the way around. Okay, you get it? So ignore the pi. This one's 1/6. So this first one was 1/6, so I wrote pi over 6. Then I have 2/6. Well, what's 2 over 6? Yeah, it's 1/3, right? So it's going to be pi over 3. All right, then I have 3/6. Well, what's 3 over 6? 1/2, right? And I have that pi over 2, so I'm good. 4/6. What's 4 over 6? Yep, so this is 2 pi over 3. And then I have 5/6, which stays as it is, 5 pi over 6. And then I have 6/6, which is just 1, right? That's at pi. So we're good there. Then I have 7 pi over 6. Then I have 8 over 6, which was the one we just found a second ago. It's the 4 pi over 3. And then I have 9 over 6. What's 9 over 6? 3 over 2. Don't I have that right there? So we're good, 3 over 2. And then I have 10/6. What's 10 over 6? 5 pi over 3. And I have 11 over 6. So 11 pi over 6. Makes sense? So you just go around once you have the pi over 4s in, go back through and do the 30-degree ones. It's a very quick way of doing this circle. Okay, everything should make sense when you're drawing it. So I get to the point where when I'm teaching calculus, I don't draw out this unit circle every single time. I don't do 1, 6, 2, 6, and so on. So if I'm asked to draw where, I don't know, 7 pi over 4 is, then I think, oh, that's almost 2 pi. How far away is it from 8 pi over 4? It's pi over 4 away, right? So it would be right here. You're almost to 2 pi. You're pi over 4 away from it. That's where 7 pi over 4 would be. So it would be this little one right there. Okay, so you kind of get used to drawing it and figuring out where these different angles are. So if I wanted like 7 pi over 6, I'd be like, oh, that's half pi, but just a little bit, just pi over 6 times. Okay, so again, to convert radians to degrees, we multiply by 180 over pi, and to convert degrees to radians, we multiply by pi over 180. So if you're stuck on the quiz, you can always do that. It just takes you a little bit longer. So if I have pi over 9 and I multiply, I want 180 over pi on the bottom, so the pi's will cancel. Cancel, cancel. I have 180 over 9, which is 20 degrees. So next one, 3 pi over 5. 180 over pi. The pi's reduce out. My 5 and my 180 make 36, so 36 times 3 is 108. Okay, 5 pi, you could do this a couple different ways. Let's say we do the conversion, 180 over pi. The pi's reduce out. 180 times 5 is 900. Or you could think about it on the unit circle. If I go around 1 time, how many degrees is that? 360. If I go around 2 times, how many is it? 720, right? If I go around another half, where am I? I'm at 900. Well, isn't that what 5 pi means? 5 pi would mean go around 1 time for 2 pi, 2 times for 4 pi, another half of a time for 5 pi. Does that make sense? Same thing. All right, number 2. So it says convert the following degree measurements to radians. So if I have 150 degrees, Now I'm going to do pi over 180 degrees. That way the degrees go away. So I get 15 over 18 pi, and then I reduce by 3. So 5 pi over 6. And it makes sense. If you look for it on our drawing, we have it. 5 pi over 6 is here. And if you see the degree measurement, it is 150 degrees. All right, 315 degrees. All right, reduce out. I think 45 goes into both of them. I think it ends up being 7 pi over 4. You can check with your calculator, but I think it's 7 pi over 4. Yeah, it's in the circle, right? So you can look there. 540. Reduce. I think it reduces out to 3. So you get 3 pi. Okay, so that's just converting. All right, so let's do the rest of the unit circle. So let's not only talk about the degree and the radian measurements, but let's find out the coordinates as well. So points along the circle. So we do this with 30, 60, 90 triangles. Okay, so this first one. So if I have a 30, 60, 90 triangle, we talked about this last time. We did a little preview of 30, 60, 90 triangles. Do you guys remember? So if I have, let's say, down here is 30, and up here is 60. Across from the 30, we had n. On the hypotenuse, we had 2n, because remember I talked about expanding it so it looks like an equilateral triangle. And then this other side was n root 3. Okay, and a 45, 45, 90 was n, and n root 2. All right. You guys remember all this? We're good on it? Okay. So let's say we have this unit circle. I'll say my, here we go, here we go, here we go. It's kind of easier on this thing. I'll draw it real big. You don't have to draw it this big. But let's say I have 30 degrees here. Okay, and then 60 here. Okay, we know that this is the unit circle. We call it the unit circle because the radius is 1. Okay, so I already drawn 1 along the radius. Would you be able to find those two different sides then, if you have one of the measurements? Yeah, what do you think?
Between the 30 and the line on the circle.
Okay, let's say we expand it and make it look like an equilateral triangle. That means that we would have 1 here, we'd also have 1 here, and 1 here, right? So what's the height of the triangle going to be? Like this distance right here. It's going to be 1/2, right? And then what's this other one going to be? 1/2 times root 3, okay? So we simplify that by writing it as square root of 3 over 2. So we have 1/2 and we have square root of 3 over 2. Now if I ask you to graph 7, -4, like algebra 1, you guys know how to do that. You go over 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4. That's what I'm asking you for this next thing. What are the coordinates of that point? How much did I go over to the right and how much did I go up? I went over to the right, 3 over 2, and I went up 1/2. Do you guys see it? I go over root 3 over 2 and up 1/2 to get to that point. Okay, that's all we're doing. So we're finding the x and the y coordinates. Okay, so let's say I'm talking about another thing in the circle. Let's say I'm talking about 60 degrees being here and 30 degrees here. I still have a hypotenuse of 1. So when I expand this triangle, it's going to be here. So I'd have 1, 1, and 1, right? So what is the base of this triangle? What's this distance right there? 1/2, right? What is the height of the triangle? It's 1/2 times root 3, right? So it's still square root of 3 over 2. So if I talk about this point right here, it looks almost identical to that last one, except they're flipped. Do you guys see it? This one you go over to the right 1/2, and then you go up root 3 over 2. So these 2 points are almost identical, except they're switched around. So on your unit circle, on the big unit circle, that's what we have. Basically, it's full of all of these 30, 60, 90 triangles. Okay, we're not going to draw those 30, 60, 90 triangles in. Here's where this first one is. Don't draw it. Just look up here. It had 30 for the angle measurement and 60 here. And we said, oh, if we have a 30, 60, 90 triangle like that with 1 for our hypotenuse, then we had root 3 over 2 here, and we had 1/2 here. So we got root 3 over 2 comma 1/2 for my measurements. Okay, that's what we just did on the other page. Well, the other one was here, right? This was this other triangle. It's still a 30, 60, 90 triangle, but now it's 60 degrees and it's 30 degrees at the top. Okay, and what point did that give us this time? What happened? They switched, right? 1/2 root 3 over 2. Now, this is where my students always get confused every single year. Okay, they can't remember which one's which. They know they have those two numbers. They're like, oh, I know one's 1/2 and one's root 3 over 2, and then they switch them. And then they miss a whole bunch of things on their quiz because they messed up the very first thing. Okay, compare these two numbers. Root 3 over 2 and 1/2. Kyle, which one's bigger, root 3 over 2 or 1/2? No. Sydney, which one's bigger? 50-50, right? Now I said the other one wasn't. Root 3 over 2, because root 3 is bigger than 1, right? Root 3 is like 1.7 something. So root 3 over 2 is the big number. 1/2 is the small number. Okay, that's all I want you to remember. Big number, small number. So when you look at this triangle here, you want to know how much you're going over and how much you're going up. Well, the bigger one is over and the smaller one is up. Can you guys tell just based on your little picture? It's bigger along the x than it is along the y. Do you guys see it? Yeah. So it's going to be root 3 over 2 comma 1/2. But the other one is small for the x value and really tall for the y value. You guys see? So it's small and then big. So small first, then big. Do you guys understand what I'm saying? Now, based on the symmetry in the unit circle, you have almost everything else. So if I go into the second quadrant, right, if I'm talking about this point right here, I want to know how much I go over, how much I go up. Up, what do you guys think? Negative root 3 over 2, comma, 1/2. How do you know it was negative and then positive? Because you're going left and you're going up, just like if you're in Algebra 1, right? Left, up. Okay, so what about this other point right here? It's negative 1/2 up root 3 over 2. These points right here are identical. It's the sign that's different. You're still going over and up the same amount. Yeah.
Why is it negative 1/2?
You just told me why it was negative 1/2, right?
Because you're saying negative 1/2.
So you're saying go backwards 1/2 and then up that much. Does that make sense? So backwards, up. All right, so these other ones. So fill in this point, this point, this point, and this point. So think about it. So fill in the various points. So the first one is over a whole bunch, down just a little tiny bit. So it's negative root 3 over 2, negative 1/2. The next one is down a little tiny bit, or over a little tiny bit to the left, down a whole bunch, right? So it's negative 1/2, negative root 3 over 2. Okay, the next one is going to be down over a little bit, down a whole bunch. So 1/2, negative root 3 over 2. This other one's going to be over a whole bunch, down a little bit. So root 3 over 2, comma, negative 1/2. Because in the fourth quadrant, it's positive and then negative. Okay, so let's go back to that other page. So let's do one last little circle. So let's say I have the 45-degree angle. Okay, my hypotenuse is still 1. Okay, if you remember from our 45, 45, 90 triangle, we had n, and n root 2. So if I have the equation n root 2 is equal to 1, how do I solve for n? Emily? So I do 1 over root 2, right? So what do I multiply by? I can't leave it as 1 over root 2. Root 2 over itself, right? I rationalize. So I get root 2 over 2. Those are the numbers you're going to memorize for the 45, 45, 90 ones. It's going to be root 2 over 2, comma, root 2 over 2. Because the x and the y are the same value. You go over the same amount as you go up. Because you have n and n. So for the 45, 45, 90s, we're going to have root 2 over 2, comma, root 2 over 2. So in this other quadrant, in the second quadrant, I'm going to have negative root 2 over 2, comma, positive root 2 over 2. In the third quadrant, I'm going to have negative root 2 over 2, comma, negative root 2 over 2. In the fourth quadrant, I'm going to have positive root 2 over 2, comma, negative root 2 over 2. So funny, the thing that people mess up on the most are these 4 points right here. Like on the quiz, they always forget those. They like memorize all those other numbers and then they forget like the easy stuff. Okay, so imagine I'm in algebra 1 and I said, okay, my radius of the circle is 1. Then what point is this over on the right side? Yeah, you go over 1 up 0, right? This one up here is going to be 0, comma 1. On the left is negative 1, comma 0. And on the bottom is 0, comma negative 1. Okay, really quickly, we'll do the degrees and then the radians. So my degrees are going to be 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Let's just do the 30s right now. So I have 0, 30, 60, 90, 120. I'm going to skip this one, 150. So I skip the one in the middle. 180, 210, 240, 270. 300, 330, and 360. Okay, so those are all the 30 degrees. Now we're going to go ahead and fill in the 45. So there's only 4 angles that I need to fill in that I haven't hit so far. They're directly in the middle of the quadrants. So I have my 45, so that's good. What's directly between 150 and 120? 135. The easiest thing to do is just add 15 degrees because it's 15 degrees away from each one. So you can either add 15 degrees or subtract 15 degrees depending on which one you want. I would just add, right? So then what about the one between 210 and 240? 225, good. And then what about the one between 300 and 330? 315, right? Okay, let's see if you guys can remember the radian measures. So you're going to fill in. So let's do the 30-degree ones first. The pi over 6s first. So remember the pattern that I taught you. So you're going to do 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 7, 6, 6, 7, 6, and so on. Remember? So I have 0. I have pi over 6. I have 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2. 4 over 6, what's 4 over 6? 2 pi over 3. Then I skip the one in the middle. 5 pi over 6. 6 over 6 is just pi. Right, 1 pi. 7 pi over 6. 8 over 6 is what? 5 over 6? Oh, wait, what was I at? 8 over 6, and then 9 over 6. What's 9 over 6? 3 over 2. So you have 3 pi over 2 here. 10 over 6. 5 pi over 3. 11 over 6. Okay, so I skipped 4 of them. I skipped this one, this one, this one, and this one, the one in the direct center of the quadrants. Okay, so those are just going to be the pi over 4. So I have pi over 4. 2 of the pi over 4s gives me the pi over 2. That was this one. 3 pi over 4. 4 of the pi over 4s gives me pi. 5 pi over 4. 6 over 4 gives me 3 over 2. 7 pi over 4. Whoops. I missed it. It was already drawn in. There it is. So 7 pi over 4. And then 8 pi over 4 was 2 pi. So you have the entire unit circle filled in. That's what you're going to do for your quiz. So you're going to go through every single thing.
So we have to memorize all of them.
Yeah, but there's patterns. So you got to know the patterns. All right, on the unit circle, we know sine is the opposite of hypotenuse. So since the hypotenuse of these triangles is always 1, when you do sine, it's really just the opposite. So let me show you an example. So if I'm talking about, let's say, 30 degrees right here. And I want the opposite over the hypotenuse. My hypotenuse is 1. The opposite would end up being the y value. It would be 1/2. So sine is always the y value on the unit circle. So what's nice is I know immediately what all these things are. So if I say sine of 270 degrees, I can, not even looking at it, be like, oh, sine of 270 is -1. I know right away because I know the whole unit circle. So that's the goal. You want to know how to do these one after the other, right? I mean, you should know because you're going to do it all the time in pre-calc and calc. Okay, and the reason, like this is super important, I remember my roommate in college, this is really dumb, her math teacher must have been a little crazy, because she said her math teacher in high school said that she loved the unit circle so much that she had a tattoo of it on her rear end. I do not have a tattoo of the unit circle anywhere. I don't feel like on my rear end that would be useful, so I don't understand why someone would do that, but apparently it's very, very important to her, so she has it on her rear, yes. I don't know if she told her class this. Isn't that weird? Like a little too much. And the same goes for cosine. Okay, so cosine is adjacent over hypotenuse. So if I have adjacent over hypotenuse would just be the x value then. So I want you to write this somewhere, x comma y. X is cosine, y is sine. It's alphabetical order for each one. X, y, cosine, sine. Okay? So when I ask you things like the next page, I'll ask you a couple of these really quickly. Sine of 30 degrees, it's the y value on your unit circle at 30 degrees. So if you look at your unit circle and you look at 30 degrees, you have square root of 3 over 2 comma 1/2. Which one's the y value? 1/2. So sine of 30 degrees is equal to 1/2. Cosine of 90 degrees, that's the point 0 comma 1. Cosine is the x value. So it's 0. Right? Sine of 45 degrees, that's root 2 over 2 comma root 2 over 2. So the sine is the y value. So it's root 2 over 2. You see how it works? So you're just filling in every single thing. The only thing we haven't talked about is tangent. So if I say tangent of, let's say, 7 pi over 4. 7 pi over 4 is down here. It's the point root 2 over 2 comma negative root 2 over 2. The tangent is the y value divided by the x value. So it'd be negative root 2 over 2 divided by root 2 over 2. Which is -1, exactly. Okay, so you could go through and you could do all of that as well. Let me end this recording.